Hello student, welcome to geography class, and this is the geography form 1, and now we're moving on to the second topic in geography form 1, and this topic is the solar system. The solar system. I hope this is not the first time you hear this topic. And this topic is not new because you already did this topic in the primary level, that was in standard 8. So in this topic, let's see now what are some of the success criteria or some things or things which you students now you expect in this topic. So the first thing which you are going to look into in this topic is to explain the term solar system. So you're going to know the meaning of the solar system. The second thing which you're going to look into in this topic is explain new developments related to the solar system. Explain new development related to solar system. We're also going to look into the the position of the Earth to the Sun, relate the position of the Earth to the Sun. We're also going to explain the shape of the Earth. We're also going to learn more about Earth movements or explain the movement of the Earth, and then we'll proceed or we'll finish this topic by looking at the results of the Earth's movement. The results of the Earth's movement. Now, let's begin this topic by defining the term solar system. The solar system. What is the solar system? So, the solar system can be defined as it is the sun and the planets surrounding it. So when we talk of the solar system itself, we're referring to the sun at the center, and that's the sun is surrounded with the planet. So we have 8 planets which orbit around the sun. 8 planets orbiting around the sun. So what are some of the planets which orbit or which move around the sun? So the first is Mercury, and there's Venus, and there's Mars, there's Jupiter, there's Saturn, Uranus, Neptune, and Earth. So however, the Pluto used to be a planet but has lost its status as a planet because of its size. That is, it is too small. So in other words, what we're trying to mean here is that in the past years there were 9 planets, and this also included the Pluto. But now we're saying that we have 8 planets because Pluto has been removed or is not now considered as a planet. Now the reason behind is that because of its size. So what's about the size? The size now is too small for it to be considered as a planet. So Pluto was saying that it used to be a planet, but it has lost its status as a planet because of that, because of its size, and it is too small. So here is a diagram of the solar system itself, and this solar system now, it comprises of the sun at this center, and then you have the planets now, and these planets now, they orbit or they move around the sun on their axis. So you can see there is Mercury here as in the first planet, and then there is surrounded by Venus, and then there is Earth, there is Mars, Jupiter, Saturn, as well as Uranus, and last one is Neptune. So also on the planet there are some moons as well as small planets. So if you can see, the planets in the solar system are some surrounded by moons, so and some smaller planets. So as you can see here, you find that on Jupiter, on Earth there is one moon. So this Earth is surrounded on by one moon. So we have looked at the solar system. Let's proceed by looking at the new development in the solar system. What are some of the major developments in the solar system? Some new development in the solar system. So the first development, or the new development in the solar system, is shifting of the poles, and also inclination of the planets, and removal of Pluto as a planet. Removal of Pluto as a planet. So let's see into details as in this, discuss more about this development. So let's start by looking at shifting of the Earth's magnetic poles. So what is it all about? So the geographical location of the Earth, North and South Pole, have changed due to the molten nature of the core, which has iron. We're saying that the geographical location now of the Earth's North and South poles have changed due to the molten nature of the core, which has iron. And this molten core is found in the Earth. So the Earth, if you look at the internal structure of the Earth, the first part, or the inner part of the Earth, is the core, and that core there is iron, and that iron now is now in the molten, as that has melted, and because of that it shifted or has changed the position of the North Pole as well as the South Pole. So it is normal for the poles to shift, but however the speed matters most. So we see here as in shifting of these poles as normal. We don't see as the problem. But now what matters now is the speed. At what speed are these shifting occurring? Or at what speeds the changes are? So we're saying that as currently the shifting is faster than before. So as you can see, the change now, we're saying that the speed of a shifting of this North and South Pole is that faster than before. So in other words, you can say that as in the past years, the most changing or the shifting of the North and South Pole was at a very slow, or was at the lower speed. But this time now, the shifting is at a faster speed. So this means that in the near coming future, the North Pole will be in the south, while the South Pole will be in the north. So now, because of the speed, the nearest coming future will see that the North Pole now will change its position or its location, as it will be found in the south, and then this South Pole will be changed now or to north. This may happen due to the changes in the magnetic field. So here there is a diagram. As you can see, here you have your North Pole and your South Pole. Now because of the shifting, you find that now this now North Pole is what is being tilted. It's been changing its location slowly, very slowly. Now, another new development in the solar system is the inclination of the planet. the inclination of the planet. So what is all about? So all the planets following elliptical orbits around the sun. So the planets, when they are orbiting around the sun, they follow in their elliptical orbit. It's like their path where these planets move around the sun. So however, all planets do not lie in the same plane, but are tilted in respect to each other. Other planets move in orbits that are more inclined than others. So as you can see here, the difference is that some planets, they move in the orbits which are more inclined than the others. The orbital inclination is not the same as tilt of a planet's axis to the orbit. So we're saying that the orbital inclination is not the same as tilt of a planet's axis to the orbit. So here is now the planet and the solar system. In other words, the planets now with their inclination orbits. So you can see how they inclined they are here. You have Mercury here with its orbit, Venus, Earth, Mars. Then you have the asteroid belt, the Ceres, and then you have the Jupiter here, and Saturn, Uranus, Neptune, as well as Eris, Makemake, Comet, and the Kuiper belt object. Now, the last development in the solar system is the removal of the Pluto from the list of planets. The removal of the Pluto from the list of the planets. So the Pluto was discovered by astronomers, but that there were a number of Pluto-like objects floating in the Kuiper belt. Hence, a doubt of Pluto as a planet. So it was discovered by astronomers that there were a number of Pluto-like objects floating in the Kuiper belt, hence a doubt of a Pluto as a planet. So let's see some of the reasons why the Pluto is considered as or is being categorized as a dwarf planet. So the first reason is that it cannot clear objects along its path. It cannot clear its object along its path. There are also two main objects of Pluto size to be called planets. There are two main objects of Pluto size to be called planets. So there are so many small objects which they look like Pluto, and in that case it's very difficult to tell that this is a planet. So the other reason is the lack gravitational force to move objects along its path. So the Pluto does not have the gravitational force which would pull or could attract objects along its path. So let us see some of the examples of dwarf planets according to size. Some of the examples of dwarf planets according to size. So the first example, the example of a dwarf planet is Eris, and this is the largest and the most distant dwarf planet. It's one of the most largest and distant planet. This means that this small planet is at very distance, and it is the largest dwarf planet. The second one is Pluto, and this is the largest dwarf planet with 3 moons. So the Pluto has 3 moons. Another one is Mercury, and this is the third largest dwarf planet. And then we have Ceres, and this Ceres revolve between the orbit of Mars and that of Jupiter. So you can find this Ceres as a dwarf planet between the orbit of a Mars the mass as well as that of Jupiter. And that the last one is now the smallest of dwarf planets, and that revolves rapidly around the Sun. So Haumea or Haumea is the smallest of all dwarf planets, and that revolves rapidly around the Sun. Now we have looked at the example of the dwarf planets according to their size. Let's proceed by looking at groups of planets. Groups of planets. So in terms of groups of planets, there are two major groups of planets. So what are they? So the first group of planets is inner planets. So these inner planets are characterized by the following characteristics. So the first one is that these inner planets, they are similar and smaller in size. They are quite close to the Sun. They have smaller numbers of moons, and their revolution takes short time. So these are some of the characteristics of the inner planets. And the examples of these inner planets include Mercury, Venus, Earth, and Mars. So these are the examples of the inner planets. So the other group of planets is outer planets. The outer planets. So the characteristics of the outer planets are these are huge as compared to the inner planets. And they have large numbers of moons. They are all made of gases, and they are separated from the outer planet by the asteroid belt. So what is an asteroid belt? You may get confused with that. So in other words, an asteroid belt is a belt which contains chunks of rock and metals that orbit around the Sun. That is an asteroid belt. So usually these outer planets, they have this asteroid belt which separates them from the outer planets. Examples of these outer planets include Jupiter, Saturn, Uranus, and Neptune. The examples of the outer planets include Jupiter, Saturn, Uranus, as well as Neptune. Yeah, that was all about the first part of the solar system. Now, for today, we can stop there. Now, in the next lesson, when we're going to meet, we're going to proceed this solar system topic by looking at the Earth's position and life activities. Earth's position and life activities. So you can read in advance so that when we come next time, when we'll be discussing about the Earth's position and life activities, you'll be able to follow the lesson well. So for today, let's stop here. Let's meet in on the next class. Have a good day. Bye.